In this video, we're going to take a look at the graph of the tangent function. We've already looked at the sine function and the cosine function, and now we're going to take a look at the tangent. We're still going to apply this and look at the relationship on the unit circle, because remember, the idea is we're unwrapping the unit circle. But remember, for tangent, it's a little bit more involved because you can't read tangent directly from the unit circle. By definition, if you use the trigonometric identity, the tangent is the sine of x divided by the cosine of x. Or if you view it in terms of your ordered pair, it is the y coordinate divided by the x coordinate. And so you have to actually do some calculations here in order to determine the value for sine. So we're going to go ahead and we'll start at 0. Even though I have the table starting at negative pi halves, let's start at 0 and kind of get a sense of what's going on here. Okay, so we have the tangent of 0. Okay, so at 0, I have the ordered pair 1, 0. The x coordinate, or excuse me, the y coordinate or the sine is 0. The cosine is 1. And 0 divided by 1 is 0. Then we have the tangent of pi sixth. Okay, at pi sixth, we have the ordered pair square root of 3 over 2, comma 1/2. The sine is 1/2, and the cosine is the square root of 3 over 2. Okay, so we have 1/2 divided by the square root of 3 over 2. Remember, to divide fractions, you flip and multiply. So we have 1/2 times 2 divided by square root of 3. Since I have a 2 in the numerator and a 2 in the denominator, they will divide out, and I have 1 over square root of 3. We've also learned we never ever leave a radical in the denominator of a fraction, so we're going to multiply by the square root of 3 over square root of 3, which gives me square root of 3 over 3, which decimal-wise, square root of 3 over 3 is going to be approximately 0.5, I believe. It's approximately 0.58, okay? So pi sixth is square root of 3 over 3, which is approximately 0.58 if you look at it as a decimal. All right, then let's take a look at the tangent of pi fourths. Okay, for pi fourths, we have the ordered pair square root 2 over 2, comma square root 2 over 2. So my sine is square root 2 over 2. My cosine is square root 2 over 2. So if we do the math, you have square root 2 over 2 times 2 over square root 2. And so then I have a 2 in the numerator and the denominator. I have a square root 2 in the numerator and the denominator. So everything divides out, and I'm left with 1. So the tangent of pi fourths is 1. Then we have tangent of pi thirds. The tangent of pi thirds, you have square root of 3 over 2 divided by 1/2. Okay, so I'm going to do the math. So we would have square root 3 over 2 times 2 over 1. I have a 2 in the numerator, a 2 in the denominator. So I have square root of 3 over 1, which simplifies to simply square root of 3. And square root of 3 is approximately, if you look at it as a decimal, it's approximately 1.73. Okay, so pi thirds is square root of 3. And then let's see if I can squeeze in pi fourths, or excuse me, pi halves. Okay, so the tangent of pi halves would be 1 over 0, because it's the ordered pair 0, 1. Sine is 1, cosine is 0. Now that presents us with a little bit of a problem, because we know, we learned in earlier math classes, you can't have 0 in the denominator of a fraction. So mathematically we say at that particular point it is undefined, that there's not a particular value. Now, using the technique that we learned earlier, that basically anytime you have a sixth, it's going to be square root 3 over 3. Anytime you have a fourth, it's going to be 1. And anytime you have a third, it's going to be square root 3. We can find the other values relatively easily. Just remember to adjust your sign for the quadrant you're in. Okay, if you think about it, in quadrant 2, you have a positive divided by a negative. So in quadrant 2, your tangent is negative. So if I'm at 2 pi thirds, I'm going to have negative square root 3. 3 pi fourths, I'd be at negative 1. 5 pi sixths, I'd be at negative square root 3 over 3. Then I get to pi. So let's think about what pi would be. The tangent at pi, again, my sine is 0, my cosine is negative 1. So 0 divided by negative 1 is 0. So the tangent at pi is 0. Then I'm around to the third quadrant. In the third quadrant, I have a negative divided by a negative, which means the tangent is positive. So at 7 pi sixths, I would be at square root 3 over 3. 5 pi fourths, I'd be at 1. 4 pi thirds, I'd be at square root of 3. Then I'm at 3 pi halves. At 3 pi halves, let's see, I would have the tangent of 3 pi over 2. So I would have negative 1 divided by 0. So again, I'm presented with that problem where I have 0 in the denominator. And again, that particular value is undefined. So we're also undefined at 3 pi halves. Now I stopped there. We could keep going on into the fourth quadrant, and we can think about what happens in the fourth quadrant. In the fourth quadrant for tangent, again, you have a negative divided by a positive, which means overall your tangent is negative. But to find these, I want us to think about rotating negatively, and you'll kind of see why when we draw the graph. So if I rotate backwards and I go to negative pi sixth, I'm still going to have a value of square root 3 over 3 for the sixth, and it's going to be negative because I'm in quadrant 4. At negative pi fourths, I would have negative 1, again because the tangent's negative. Negative pi thirds, I would have negative square root 3. And negative pi halves is the same thing as 3 pi halves, which we have already determined to be undefined. So at negative pi halves, we again are undefined. Okay? So now let's take a look at our graph using these values. Okay, again, the idea is we're unwrapping the curve. Okay, so I'm going to draw us our grid. We have our vertical axis, which represents the y, and we have our horizontal axis, which represents our x. On the y, we usually focus on the maximum, which is 1 and negative 1 usually. we usually use our quadrantial angles. So you have 0, pi halves, pi, 3 pi halves. We usually go out to 2 pi, but I'm going to back up and go to negative pi halves. Again, it just kind of helps me get a better picture here of what's going on. Okay, so if we think about it and go back and look at our table for a minute, at those points that I've already marked, I have negative pi halves is undefined. And visually, when your graph is undefined, we represent that using an asymptote. Okay, it's called an asymptote. Should have learned about those in algebra. It is vertical, and so the way we show it graphically is we draw it in using a vertical line. We also found that it was undefined at positive pi halves and at 3 pi halves. So I have those asymptotes drawn in. And if I go back and look at 0, my tangent value was 0, and at pi, it was also 0. So using those quadrantial angles, which we normally use, we really don't get enough to draw the picture. So we typically add in a few other points, and an easy one to add in is kind of this halfway point between 0 and pi halves and between pi halves and pi. So halfway would be pi fourths, 3 pi fourths, 5 pi fourths, or if we're going backwards, it would be negative pi fourths. So if we look at those values off of our table, at the fourths, remember we were at either negative 1 or positive 1. So at negative pi fourths, I was at negative 1. At positive pi fourths, I was at 1. Positive 3 fourths, I was at negative 1. And then positive 5 fourths, I was at positive 1. Now I could add in a few other values in there and look at the values for pi 6 and pi thirds, but if I get a general sense of this thing's going to kind of come up and do something like this. And it has to stay between the asymptotes. Remember, for the asymptotes, okay, you can get really, really close to it, but you never cross it and you never touch it. It's like fence post. You have to stay between the fences. Okay, so there's a picture of the tangent. Now, the way I remember it in terms of, okay, what does it look like? I remember that at my starting point, which is typically negative pi halves, I begin and end with an asymptote. In the middle, I'm at 0, and then the halfway marks, I'm at negative 1, positive 1. Begin with an asymptote, end with an asymptote. Midway, I'm at 0, and at my in-betweens, I'm at negative 1, positive 1. The other thing about tangent is if we think about how far do we have to go to get an entire picture. Well, if I start with an asymptote and I'm at negative pi halves and I go to 0, I've gone pi half units. And then from 0, I go another pi half units, okay, to the other asymptote. So pi halves plus pi halves is 1 whole pi. So our period for the tangent, the amount that you have to rotate to see the entire picture, is only 1 pi. Now remember, that's different from sine and cosine, because for sine and cosine, we had to rotate a full revolution around the unit circle, which would have been 2 pi. Okay, so let's take a look at some of the characteristics of tangent. It is a function. It would pass the vertical line test. We can use any number that we can think of except odd multiples of pi halves, which means at pi halves, 3 pi halves, 5 pi halves, see, they're odd. 7 pi halves, 9 pi halves, I'm going to have an asymptote. My range is all real numbers because notice with the tangent, there are arrows on the end of these curves, which means they keep going and going and going and going. So the tangent curve never really maxes out. Again, it is periodic, and I mentioned that the period is 1 pi. It is symmetric to the origin, which makes it odd. Your zeros occur at odd multiples of pi, okay? So your zeros occur at at multiples of pi. Okay, so your zeros occur at multiples of pi. Again, there's no maximum and minimums because it does continue on forever. Your y-intercept is at the origin, or 0, 0, and those vertical asymptotes occur at those odd multiples. Now, there's not near as many uses of tangent as there were for sine and cosine, but a few that I found. One is that electricians use their knowledge of the tangent curve to be in conduit to do house wiring, or really any kind of wiring. Architects can use the tangent to determine the height of a building if they need to somehow avoid that particular height or that particular building. NASA also uses tangents to figure out how to launch space probes and then have an idea of where that probe will be at any given point in its pathway. Okay, so the biggest thing to remember is with the tangent, you begin, you end with an asymptote, midway at 0, then your in-betweens, you're at -1, +1.